Hello everyone.
Hi.
Thank you so much for being online. So sorry for the inconvenience. Can you guys hear me?
Yeah.
Thank you. So, thank you, Isabel. The plan for today is to do recitation 3. That's because I was supposed to give you a homework on our first recitation, which I didn't realize. So I was supposed to do week 2 in class and give you week 1 as homework. But I did the opposite. I did 1 in class and I forgot to give you 2 as homework. So my plan for today is to do week 3, go over a few questions, and then do a few questions from week 2 so that you can do week 2 and week 3 together. Okay? And I believe all the knowledge to do this, the knowledge you need to do this 2 recitation, you already have them from your lectures. Any question? Any comments? Any concern? Anything before we start? Nothing? Great. So week 3. In week 3, we will talk about polynomials. How do we find the degree of polynomials? How do we know their end behavior? All these things. And if I'm not wrong, you already had the lecture on these topics. Did you guys have the lecture already on these topics? Anyone? Yes? Great. That means I don't have to give you all the details. I can simply refresh your memory with few important information. So we have 4 types of polynomials. Let me draw all 4 here. The first type is, let's say we have even degree with positive coefficient. Even degree means 2, 4, 6, 8, those degree. So one best example of this type is y equals x squared. Now y equals x squared, you know its shape is parabola. So on the left side, our y is going up, so is also on the right side. It means when x is going to negative infinity, means on the left side, our y is going to positive infinity. This is the end behavior. Similarly, when x is going to the right side, our y is going to upward. So when x is going to positive infinity, y is still going upward. So this is the first type, even degree with positive coefficient. Now we have even degree with negative coefficient. Best example, same thing but with a negative sign, y equals negative x squared. And we know y equals negative x squared is an upside down parabola. So what is happening here? When x is going to the left side, our y is going downward. When x is going to the left side, y is going upward. Sorry, y is going downward. So negative infinity. Same thing when our x is going to the right, our y is still going downward. So when x is going to the right, means it's becoming bigger and bigger. Our y is still becoming smaller and smaller. So for even, we have 2 choices, positive, negative. When we have positive coefficient, our y is both going up. When you have negative coefficient, both y's are going down. Second thing we have is odd. Let's say we have odd degree and positive coefficient. Now, odd degree positive coefficient, the best example is y equals x cubed. And y equals x cubed has this shape. The left side is going down. It means when x is getting smaller, y is also getting smaller. And when our x is getting bigger, y is also getting bigger. So when x is getting bigger, y is also getting bigger. Lastly, we have odd degree and negative coefficient. Same example, y equals x cubed, but this time it's negative x cubed because we have a negative coefficient. And the graph of negative x cubed has the other way around shape. So when x is getting smaller, our y is getting bigger this time. So when x is getting smaller, y is actually going bigger. And when our x is getting bigger, our y is getting smaller. When x is getting bigger, y is getting smaller. So if you can remember these four characteristics of four different types of polynomial, then you can find end behavior for any type of polynomial. Okay, so we need to find end behavior as well as the degree. Now, for degree of the polynomial, we have two scenarios based on what type of polynomial is given to us. If you have a polynomial in factored form, for example, let's say ax plus b, x squared plus c, x minus d squared. Okay, something in factored form. When you have a polynomial in factored form, our degree is the sum of all the powers. So first polynomial, first factor has power 1. So we take 1 for the x. Second factor has, we have x, 2 of them. So it's 2. The third factor has 2 here on the outside. So it's 2. Let me actually give another factor here so that you can see what happens when you have double degree. When you have double degree, you actually have to include this 2 with the 3. So you multiply 2 and 3. So our second factor has not only 2 factor, it's actually 2 times 3 factor. Not 2 degree, it's 2 times 3 degree. And lastly, the last polynomial has degree 2. So the degree of this polynomial is the sum of all the degrees on x. Now, if your polynomial has standard form, a x to the 100 plus b x to the 99 plus, let's say, c x to the 300. Okay, so in this case, the degree of the polynomial is the highest power. Whatever you have, the highest number on x, that's the degree. So that's how we find degree of the polynomial based on what is the format. If it's in factored form, you add all the powers. If it's in standard form, then you just take the highest degree. So in a standard expanded form. Okay, so let me do one or multiplicity. Now roots with multiplicity. So multiplicity means how many times you see the same x-intercept. Okay, so once you solve for x-intercept, how many times you see it? That's multiplicity. How many times you, or what's the power of the factor? Yeah, that is more understandable. Multiplicity is the power on a factor. Factor, okay? Not on x, on a factor. Now let me do b. So in b, we have degree. So this is in in factored form. So our degree of the polynomial is 1 for the first one, 2 times 3 for the second one, 2 for the next one, and 7 for the last one. You take the powers on every x or on the factor, and then you add them. So we have 7, 8, 9, 10, 16. So our degree of this polynomial is actually 16. Then we are looking for what? End behavior. So we have degree 16, which is an even degree. So we have even degree, and look at our leading coefficient. It's positive. So even degree with positive coefficient. It's same as this scenario. So when and behavior, B. Behavior start with B. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, sorry, my bad, what I'm saying. It's parabola, so it's going upward in both direction. Y is going to positive infinity. This is the end behavior. Okay, so we don't know the shape of this graph, but we do know it's an even degree positive coefficient. So it will have something like this when both ends will go upward. So when x is going to the negative infinity, y is going positive infinity. When x is going to the positive infinity, y is still going positive infinity. We don't know the shape, but this is a sketch of how it should looks like. Any questions so far? No. So we did degree, we did end behavior, now roots with multiplicities. So root means x-intercept. So you take each degree. So let me make it bigger so that I have enough space for each one of them. So roots. The first factor is 4x. So we said 4x equals 0. Second factor is x squared minus 9 with a cube. So we said it equals 0. The third factor is x squared minus 2, we set it equals 0. And lastly, we have x plus 6 to the power 7, we set it equals to 0. Can you please zoom out so that I can finish the problem? Okay. So set every factor equals to 0 and then solve for x. If you solve for x, here gives us x equals 0. And we see this factor only once, so it has multiplicity 1. In the next factor, we have x squared minus 9. So you take the cube root of both sides, you get x squared minus 9 equals 0. Now this factor has multiplicity 3. So when you solve for x, each one of them we are going to see 3 times. So we have x plus 3, x minus 3 equals 0. Because x squared minus 9 is x squared minus 3 squared, so we can factor. We get x is negative 3 and x is positive 3. Each one of them will have multiplicity 3 because this factor has power 3. The second one, we have x squared minus 2. So we have x squared equals 2. And then we take the square root. So x is plus minus square root of 2. In other words, we have x equals negative square root of 2 and x equals positive square root of 2. And we see this factor only once. This is happening only once. So each one of them will have multiplicity 1. And now lastly, we have x plus 6 to the 7th power. That gives us x plus 6 equals 0 and x is negative 6. And we see x plus 6 7 times. So multiplicity here is 7. And that's it. That's all you have to do in question 1. For A, you're going to do the same thing. Find out degree by adding all the powers. And based on the degree and leading coefficient, you do n behavior. And then from each factor, you solve for x. And see what's the power for every factor. That would be the multiplicity for each factor. Sorry, each root. Any question? Any question from anyone? Any comments? Any concern? Any complaint? Anything? Nothing? Okay, then. One thing I should mention here is that anytime you have even multiplicity, it means you cannot cross the x-axis. Can't cross the x-axis. So you can only touch and then you have to go back. For example, you can have something like this or something like that. Okay, where you cannot cross, you just touch the x-axis and then go back to where the same direction, toward the same direction you came from. For example, here, you go up to the x-axis, touch it, and then come down again. So even multiplicity you cannot cross. And for odd multiplicity, the higher the number, the more you stay on the x-axis. The higher the number, the more you stay on the x-axis. What does that mean? So here, we have a multiplicity 1 for x equals 0. So when x is 0, we are going to cross the x-axis. So our end behavior says the left side is going up. And then, oh, sorry, I have other numbers also. This is 3 and this is negative 3. I missed the negative sign. So we have on x-axis, you can cross the x-axis either this way or you can cross the x-axis this way, straight crossing. But look at here. For x equals 3 and x equals negative 3, you have multiplicity 3. What does that mean? It means when x is negative 3 and when x is positive 3, you're crossing the x-axis either this way or this way. So you're staying on the x-axis for a little bit and then you're crossing it, just like cubic function. And here for one multiplicity, it's a straight crossing. It goes straight away. But when you have a power 3, you go in a cubic way. So you slide down a bit and then you cross it. Now here we have a multiplicity 7. What does that mean? When x is negative 6, you're lying down so much and then you're crossing it. So the higher the odd number is, the more you lie down on the x-axis and then you cross it. Okay. So even means you cannot cross. Odd means the higher the number, the slant way you go. You cross the x-axis. Any questions so far from anyone? No question? Okay, I'm recording this, so I'll send you the link after class. Now, question 2 says the other way around. All the informations are given. Now, sketch a graph and find the polynomial. Write the polynomial and sketch a graph. So, between A and B, which one you think is harder? Which one you think you need my help? B? Good. Okay. B is kind of harder because it has imaginary number. So let me make it bigger so I have enough space. So we have degree 4 polynomial. Okay. And then we have a leading coefficient -1. So the format is y negative, and then something at the end we will have total degree 4. Now they give us roots 1, 2, 3. They gave us 3x-intercept, but they're telling us we have degree 4. That means one of the power they did not give us. So the first one is x equals 1 minus I. The second one is x equals -3. And the last one is x equals 0. These are the 3 roots they gave us. Our job is to get the factor from the roots. So get the factors from the roots. How do you do that? You just have to do something so that you see 0 in one side. Okay, that's the rule. So this already has a 0 on one side. So from here, our factor is the left side, x. So one of them, we didn't even have to do anything. It's already factored. For the next one, in order to see 0 on the other side, we have to add 3 to both sides. So we get x plus 3 equals 0. So here, our factor is x plus 3. So the equation we have is x plus 3. We found 2 of them, and we still have 2 more to go. Now, in order to see 0 in this side, we need to subtract 1, add I. Subtract 1, add I. So they cancel out, which is 0 in one side, and we have x minus 1 plus I. Okay, whenever we have I, that means we are working with imaginary numbers. X minus 0 is same as x equals 0. So x minus 0 is same as x. Okay, so you don't have to write it, but if you want, you definitely can. You don't have to. So the first root is an imaginary root, and every imaginary root, they actually cannot live alone. Even though they gave us only one imaginary root, but in reality, we actually have another one, which they did not give us. But we know it has to be there. The other root, which they did not give us, is 1 plus I. Good job, Vineta. So anytime you see I, that means you have another one. If you're given minus I, it's plus I you have. If you have a plus I, that means you have a minus I. So they're conjugates. They cannot live alone. They always come in pairs. That means we need to subtract 1 and subtract I here. Subtract 1, subtract I. So we get 0, and we have x minus 1 minus I. Now, this factor is okay, it's realistic. This factor is okay, it's realistic. But if you look at these two factors, x minus 1, oops, x minus 1 plus I and x minus 1 minus I, they don't look realistic. They look fake, imaginary. So we actually never have any polynomial with imaginary x in it. That's why we have to multiply them so that they become real. because right now they're not real, they're imaginary, they have I. So when you multiply, you can multiply individually one by one, or we can simply use a trick. If you observe, look what do we have. Highlights. We have x minus 1, x minus 1. The same first two term. And then look what we have. We have a minus sign here, a plus sign here, and a minus sign here. And then we have I and I. So if you observe, this is actually x minus 1 plus I and x minus 1 minus I. So they give us x minus 1 square minus I square. This is same as x plus y times x minus y. When you multiply to conjugates, you get the first one square minus the second one square. So our first one is x minus 1, so x minus 1 square. And then our second term is I, so we get I square. Now still it's not realistic. We still have an I square. So do you guys know what is I square? If you have two i's, I times I, it becomes real. Which real number? Good, -1. But we have a negative minus 1, sorry, minus -1. So it turns into a positive 1. And now we are happy. We have no more imaginary things in our polynomial. So we expand this so that we can combine with the 1. And when you expand, you get x squared minus 2x plus 1. So this is the factor we have, but as you see, we can combine them. So the final factor we have from here is x squared minus 2x plus 2. So we write this down here. X squared minus 2x plus 2. So this is the polynomial they are asking us. Now they want us to graph it. Well, when you graph it, let me change the color to blue. So we have two real zeros. One is at 0 and another one is at -3. 1, 2, 3. And then we have two imaginary zeros. No, not 5 degree. We still have 4 degree. How? Because from the third one, we take the highest degree. Because this is expanded form. In the expanded form, our degree is the highest degree. So we have 2 here, 1 here, and 1 here. So when you combine these, we have our degree 4. So we have 1, 0 is 0, and 1, 0 is -3. These are real, and the imaginary one is x minus 1 plus I, x minus 1, sorry, the other one is 1 minus I and 1 plus I. So this is 1. Minus I means little bit before 1, and plus I means little bit after I. So these are imaginary. I don't know where are they, above the x-axis or below the x-axis. I'm not sure. But since we have a negative, an even degree with negative coefficient, so we'll have a shape like this. At the end, both of them going down. So here, our left side will go down. We are going up, and then we have to come back. Oh, so that means our 0 will be here and here. So both going down. So first on the left side, you are going down, and then we are crossing the x-axis through the x-intercept, then we are crossing 0, and then we have two imaginary roots, and then we are going down forever. So imaginary root means we have a little bump, okay, next to 1 plus I and 1 minus I. Little bump here, and then we are going down. They're not real. The one we do see is what we have given to us as real numbers. This is we see, and this is we see. But here we don't see, here we don't see. These are imaginary roots. So our shape will be similar to this shape, and our polynomial is y minus x, y equals negative x times x plus 3 times x squared minus 2x plus 2. Any question? Let me make it a little smaller so that you can see the entire screen. Was anything unclear, confusing? Any question? Could you explain how you got the equation for the polynomial? Sure. So we get the equation from x-intercept. They gave us three x-intercept. One is 1 minus I. So here I set this x equals 1 minus I. The second one is x equals negative 3. So I set x equals negative 3. And the last one is x equals 0. So I set x equals 0. Now these are zeros. But in order to find the equation, we don't want the 0, we want a factor. So from each 0, we get a factor. How? By bringing everything to one side so that we have 0 on the other side. This one already have a 0 on one side. So we have nothing to do here. So from here, we get the factor x. So that's how we have x. And they're telling us our leading coefficient is -1. So I have a -1 here. Now the second factor is x equals -3. Now in order to see 0 in one side, we need to add 3 to both sides. So we have 0 in one side. If you see 0 in one side, that means whatever you have on the other side, that is your factor. So our second factor is x plus 3. The outside of the x came from x equals 0. Now is it clear to you? Okay, so we found the first factor, we found the second factor, and then they gave us one imaginary root. But as you know, imaginary numbers are very weak. They always come as a conjugate. So even though they gave us only one of them, we have to do another one by ourselves. So we get the second factor by bringing everything to one side. But no polynomial has imaginary numbers, so you must multiply them out. And when you multiply them out, this is what we have at the end. And then you combine all three factors with a negative sign in the front to get your equation. Okay. Any other question, comments? Anything? Nothing? Okay. Now this page is nothing but matching the equation with the graph. So I'll do only one, and then I want to go over two, recitation 2. Where can you get this sheet? It's on Lumen. I'll show you. Let me finish one of these here, and then I'll show you how to find this in the Lumen. And also, you have to upload them on Lumen. But I'll show you that later. So for example, here, let's see. Let me do the last one. So which graph is the graph of this polynomial? Well, yes, you can use calculator, but in the exam, you're not allowed to use graphing calculator. So that means you have to find them manually. This is what I'm showing you, how to find them manually. So from each factor, we need to know what is our x-intercept. So the first one is x squared plus 1 equals 0. I will show you Zichi. The first factor x squared plus 1, so we get x squared equals -1. We take the square root, so we have x equals plus minus I. That means we have to imaginary solution here. And then the next one is x minus 2 equals 0. That gives us x is 2. The last one is x minus 4 equals 0. That gives us x equals 4. And all of them have degree 1. So they all are crossing the x-axis either this way or that way. And now you see what's the degree of this polynomial. So you have to count. The first one has 2, then we have 1, then we have 1. So we have degree 4. So we have even degree, and our leading coefficient is positive. Oh, positive coefficient. Even degree positive coefficient. It's like x squared. Both ends will go up. So let's see which graph has 2 and 4 as x-intercepts. And both ends are going up. They are going one up, one down. So definitely not here. Here we have 3, 1, 1, 3. We have too many, not this one. Here we have 4 and 2 and going up. And we have 4 and 2 going up. So this is 4 or 6. 6, my bad. So this is the graph of this polynomial. And you see we have a little bump here because that's because we have an imaginary root before 1. Little bit before and a little bit after 0. Okay. So that's how you find the graph of polynomial. Any question from anyone? Any comments? So imaginary number, it's they don't cross the x-axis, they just give us little bump. So we have a plus I and we have a minus I. So plus 1i and then minus 1i. So plus 1i, it means plus 1 means it's a little bit after 0 somewhere. And minus I means after 0, little bit 1. So 1i on the left, 1i on the right. So we have a little bump before and after 0. So something like this. Okay. And usually most instructors, they don't care about imaginary roots. So if your instructor doesn't even care about the root, you don't have to worry about that. But if you want to draw more precisely, then yeah, showing little bump makes it easier. Any other question? No? Then let me show you where do you find all these worksheet and how do you upload them. So you go to Lumen. You go to class. Let me go student view. See here, the yellow bar is this recitation worksheet. So all the worksheet we are going to go over this semester, these are here. So we are doing 3 today. So you can find it here. And then you'll do 2 as homework. Okay. This is 2. And in order to upload them, they're not visible yet, but I'll make them visible. You'll see another option here. It says recitation worksheet uploads. So in here, you're going to upload them. Don't bring it to the class, just upload it on Lumen. So even if you use online, like the way I use computer to write things, So if you use tablet or computer to write things, you don't even have to print anything out. Okay. Yes. Please upload all of them here. Recitation worksheet upload option. When you click there, right now it's hidden, but I'll make them available. So in order to upload, you're going to click on the link and then start. And it says a first question. Click on the first question and it says choose a file. Now there is one problem. You can only upload one file. That means you have to convert them into one PDF file, because I don't think you can upload more than once. Let me see if you can upload more than once just to test. Recitation. Said I don't have my recitation. Oh, here. Can I upload more than once? No, you have to upload only one. So yeah, only one file can be uploaded. So convert the 2 pages into one PDF file and then click on choose file, upload the file, and then submit the question, submit your attempt. Let me read what message I have. Do you have to print out the paper? You don't print out anything. Just if you write them online, just fill them out online and then save as a PDF file and then upload here. Can I upload the first week? Yes, that was I was going to tell you. Like from now on, I'm not going to collect in-person worksheet. Instead, upload everything here so that I can submit your grade here. So we used to have Blackboard, but from this semester we don't have Blackboard, we have Brightspace, and I hate uploading things on Brightspace. So that's why I decided to upload everything on Lumen. In order to upload everything on Lumen, first you have to submit things, your file. So submit, access your file under recitation worksheet. And then once you're done, you just upload everything here. Let me see if I can change here, modify. Shawless. The block. Okay. So I believe now you can able to see everything. Let me see the student view. Yeah. So now you can see everything. So due date. For now, I said the due date for past 3 is 22, but I think 22 will be you may need more time to understand what's happening here and how to do everything here. So I'll actually give you more time after 22. How about before next Wednesday or by next Wednesday? If you already given me physical copy on last class, then don't worry about uploading it. And if you did not submit anything on last time, from now on, please upload everything on Lumen. I'm not going to collect any more in-person worksheet. And I wanted to go over week 2, but no, we don't have time to go over week 2. We have only 2 more minutes. Any question? So again, let me show you how to upload. You just click on upload, start, and then you click first question and then choose a file. But again, remember, you can only upload one file. So make sure you convert them into PDF file and then you upload. So one PDF file, upload, so open and then submit question. Yes, next week we will meet in person. Next week we do have class, right? Let me just make sure we do have it. Let me see our calendar. Okay, so today is 19. Next week. Oh, you have your Monday on 24. So you have your exam on Monday. Good luck with your exam, guys. Exam is on Monday, and then we have our recitation on Wednesday. Oh, let me show you something. Probably I have one video from last time. Oh, where do I upload all these things? So I actually upload everything here. You see here. So when you go to this playlist, these are all the recording from last semester and exam 3 review. I used to do reviews with my recitation students. So explore this. Probably you'll find exam 1 review. I don't have the title. Probably I do. Okay. And so I'm going to post our recording here. I posted the first recording and today is the second. So I'm going to post our second recording here. You can access them anytime. Do you print out next week's recitation worksheet? Print out next week recitation worksheet. You don't have to print them out. I'll print them out for you. Or actually, let's do this. I noticed that when I print them out, we have left so many leftover every class. So I'm not going to print anything out anymore. You should bring your own recitation worksheet so that if you are absent, we are not wasting any ink. So yeah, thank you, Anana, for reminding me. Print out all of your recitation next week if you're attending the class. We are going to do recitation 4, right? Let me see the schedule. Yep, week 4. We are going to do recitation 4 in class, and then you're going to upload them once you're done with the recitation. Okay. Oh, he pushed it back to Thursday? Cool. So next week, Thursday. Then maybe I can do a little review with you on Wednesday. Yeah. I can tell you what to do in the exam. So we have to do yes. So you need to do recitation 1, 2, 3. And even though the due date here is 22nd, but I'm gonna change the date. What is it here? I'm going to I'll give you one more week. I mean, yeah, one more week till next week Wednesday. So your time next week Wednesday time to upload recitation 1, 2, 3. And then after that you're going to upload recitation every week by Friday midnight so that I can grade them on Saturday and Sunday. Okay. Any other question, comments, anything before you leave? Exactly, you can do that, Lichi. You don't have to print out if you use tablet to write them on. And once you complete everything online, I mean on your tablet, save that as a PDF file and then upload. No problem. Any other question from anyone? Any comments? Concern? Complain? Nothing? Okay then. So thank you everyone for being here. We'll see each other again in person next week.
Thank you.
No problem. Have a good day and have a good rest of the week. You too. Bye bye.